Hello everyone, this is Tas and welcome to my new TouchDesigner tutorial. And today I'm gonna show you how to create this kind of broken mirror effect, or it could be a mosaic or stained glass effect, or it could be some weird displacements like something like this one. And but first let me explain to you what are you seeing right now. The idea of it came to me recently, and probably I'm not the one who invented this, but I haven't seen anything like this before, so I don't know is there any common name for this kind of effect or not. And idea for this is normally, if we're rendering or doing raymarch rendering, we have one camera and render everything from one angle. But what if we took some kind of texture, some kind maybe like this mosaic effect, and let me pause. And for every pixel in our rendering, we would render from different angles, from different camera positions. So we have like a default camera position, and we move our camera. For example, for this region, we would move on a X scale for the value of our red channel to, or maybe we'll mathematically do something with this value. Anyway, we would move our camera position horizontally based on red channel, vertically based on green channel, and on the z-axis based on blue channel. So almost for every of our pixel, depending on what kind of noise or what kind of input texture we use, for many of our pixels, the camera position would be different. And that creates a render that basically it's a render from different angles. And I will show you how to do it with normal, standard TouchDesigner polygonal rendering. It could be just polygonal geometry or instances or anything else. And also I show you how to do it with raymarching. The code is super easy, and even if you have zero GLSL experience, I hope you could understand what we're gonna do today. But first, the good news is that for raymarching it's very simple to do, and it works like I explained to you. And for standard rendering, and let's dive into it. For standard rendering and TouchDesigner setup, we could have only several cameras, and our renders always looking for the cameras. We could have several cameras, but we couldn't or almost couldn't do like millions of cameras to render every pixel from different cameras. So what we do with render, polygonal render, it's not a real effect like in raymarching, but more like a faking this effect with this kind of displacement. But I know that maybe many of you don't do raymarching, don't know what is it. So first let me show you this fake version of the same effect, because the code for it is pretty simple. And we would almost start from scratch here. Why I'm talking always, it's because we would use just a typical render. Geo, camera, light, some kind of geometry is a standard teapot. Nothing crazy here. You could do any kind of render setup. with instances, without instances, with any type of material, any type of camera, light, everything. Because the only difference I made here is the little GLSL code, and let's paste this GLSL 1, and let's start editing a code. What we need is second input with our displacement texture, and to make everything very simple, let's make me sorry, not a composite, just a constant top, and let me connect constant top instead, because it would be easier to test everything with single color for the whole texture. It's just for testing. Okay, so here's our code, and we could uncomment this and delete this string, and now it shows our teapot. The background comes from here, from a transform node. The code tells us we telling to output texture as an input, as our first input or our zero input on the same pixel position. VUVST meaning that took incoming pixels from a texture and put it in output in the same position. But we don't want that. What we need instead? We would like to change this to some kind of different UV position. Let's call it UV, and let's make a variable. Let's call it vec2 UV, and for now let's leave it as it is, a VUVST. And we need to displace it somehow. First of all, let me copy paste the same code, because we need to sample our texture, and let's call it cam displace, and it's on our second input, so number 1. And here we need VUVST, so we need normal pixel positions. And for red and green channels, for horizontal and vertical, everything is super simple. We just add cam displace RG channels, and now it's working. You don't see our teapot because we have values 1, 1, 1, and if we move it back to 0, here's our teapot, and if I move something not working, it's because I need to set it to 16-bit float. And now if I change the color to less than 1, it moves in one direction, and more than 1 with another direction. Okay. And probably you could achieve the same effect with just display stop. Here with display stop you could set horizontal source, vertical source, and tweak these values and get the same. But what we need also is to do something with Z position or the camera zoom. So we want to be able, based on our blue channel, let's also make it 0, based on our blue channel, either zoom in or zoom out. And how we could do this? To do it, we will need to divide our UV with the value of displacement on a blue channel. And Okay, but it's not working because right now if my blue channel is 1, so if we divide something on a 1, nothing changes, but if we divide less than 0, less than 1, it becomes smaller, and more than 1, it becomes larger. But here is a couple of problems. First of all, I would like to have default value as 0, because it would be much easier to work later with noise texture, for example. We could make a noise with a default position offset equals to 0 and have some amplitude, so our default value should be equal to 0. So how can we do this? We could just add a 1 here instead of having it here. So here's our 1. And now again we could go with make it bigger and make it smaller. The second problem is that we zoom in and zoom out from our left lower corner and not from our center, like in normal camera zooming. And that is because in GLSL, the center of the beginning of a coordinate starts here. Not here, not in the center, but here. So here we have a 0, 0 on x and y, and here we have 1, 1. And to do something with that, we need to move our texture. And how could we do this? Let's first, because we need to move it before we do any displacement, let's leave it UV here. Now nothing has changed, I just changed the position. Now we have here view VST and adding displays a bit later. And now we just subtract 0.5. So if we have here 0, 0, when we subtract it, here would be minus 0.5. Plus 0.5, and here where was 1, 1, it would be 0.5, 0.5, and the 0 on the center. And then we need to bring it back, because here for our texture sampling, we will need again to make it GLSL way, so 1 from 0 to 1. So we subtract, do our transformation, and then add it back. Now our zooming should work fine. Let's test it. Yeah, zooming in, zooming in, zooming out. With a 0 it's unzoomed. And the only thing I don't like is that if, for example, on y-axis I move upward, if I increase value it moves downward, if I decrease value it moves upward. It's a little bit unintuitive, so let me change the plus to the minus here, and now it should work more intuitively. Yeah. Okay, and actually that's it. And let's test it not with our constant texture, but with our tiles. Yay, it works. And depending on what kind of input you'll have here, you maybe will need to change our, to have a, for example, math top or level top or anything else, and to add to maybe change the range, or doing like I'm doing here, to multiply it. The only thing is, because we are not really rendering it from different position, if we do it, if we set the value pretty high, it looks a little bit strange, because it moves like a displaced. It's not from different angles. If it's very upward, it doesn't look like it captured from upward. It looks like we just slide in our pieces. So probably it's good to make the value quite small. And also, because our texture is going from 0 to 1, if I move it more than 1, oops, not here, but here, if I move it more than 1 in any direction, it disappears. So you need here the values here to keep it between -1 and 1. Okay, and that's it for the rendering. So all you need to do is set up a render, place input textures. If you want, also you could use edge or something to imitate the cracks, and I could compose it here with under, and that's it. Everything done by this simple GLSL thing. And let me show it with the different textures, because I will share my components for Voronoi and Voronoi cracks with my Patreon supporters. And if you're not one of that, you could use just a simple noise top, for example, or any other kind of tops, ramps, different kind of noises, anything. For example, with a simple noise top, you could either go to more like displacement, a smooth displacement, or you could set exponent to 0 to have sharp edges, and it looks more sharpy with more like tiles. And for this particular look, it's better to not to have constant movement, but to do it from time to time. But it's up to you how to control the movements. Okay. And I'll talk about Voronoi in the end of this video, but first let me show you what you could do and how you could work with the same effect, but much better actually, with raymarching. Okay, here's our raymarching. And by the way, if you're not familiar with raymarching, I have a playlist on YouTube with my raymarching tutorials, and I also have this GitHub repository with a lot of files. And actually, if I turn off, or I could delete this effect here, and let me instead put this, and okay. Sorry. Let me put it here. Ah, okay. I could just output this for now. Here is standard raymarching. I didn't change much of the code, and you could, if you go to this GitHub repository, this is basic version 2. Recently yesterday I uploaded basic version 3 file. This one uses a different approach for the camera. It's much better if you do just normal raymarched stuff without messing with the camera, like we do today, without any camera displacement. I'll recommend you to use basic version 3, and for the arrays version 2. But since we're gonna mess a lot with the camera and displace it, version 2 works better. And by the way, my tutorials based on this version of the files. So go and grab, and if you open it, it would be almost like that. The only difference is that it would be just a normal sphere here. And I prefer to show you effect with not a sphere but something more complex because it's much simpler to understand what's going on a complex geometry like a teapot or head. And if you're interested in this head, you could go on to Shader Toy, and this is actually a head created by TD Hooper, and you could, if you follow my raymarch tutorial, you could copy paste the geometry code of a head. It's quite a lot of code, and because it's quite a complex of geometry, and copy paste it instead of sphere, like I already did here. Everything else in this code is default code, same as here on GitHub. Okay, so now we have basic raymarching, and again it could be any raymarch. You could use different colors, you could do some kind of crazy thing with lightings and with positions and anything, space distortion, anything you want. And we want to go from this to our displacement head. So what's our connections? Again, as in previous example, with polygonal rendering, we need to input our texture and also to make everything looks a bit more easier to explain to you. Let me also put constant with 0, so I could show you the same way like I did before. Okay, scroll all this down to the end, and here we have our camera. This is default code, and we need to do something with that. First of all, let's also input our cam displace, and this is a texture std2d inputs on the first input vuv.st. All right. And by the way, when you save the file, because this geometry is super complex, sometimes the touch freezes for a couple of, or for a fraction of a second to compile this GLSL code. And now we need to, here is our camera position that defines here in the variable uCamera. And here's our XYZ camera position, and we simply displace our camera position on RGB value. And compiling, everything works. And the good thing about why I call this a real effect and not a fake one like with polygonal rendering is because we really could change the position of our camera. For example, if I move my Y channel, nothing going on. Why nothing going on? It's again probably because I forgot to switch to the 16-bit float, because we need negative values as well. And now if I decrease values, we watch to our model from below. If I increase, we watch it from above. And let me turn off the rotation to make it even more simpler. So we could watch it from a different angles, from a different right and left, and also back and forth. And now let's switch back to more interesting tiling. And actually I would prefer to look at this. Okay, that's working. And this is a real camera displacement. The one thing we could improve this is here on the camera we have a fourth value, which is 60 right now. And let me switch back. And this is field of a view. So we could make camera more like a fisheye or more like a telescopic camera. So it's basically, it's a little bit similar with a zoom in, but also it's a bit more complex. And since we have this value, we could, and since we also have RGBA channels, so we already do something with RGB, is move X, Y, and Z, and we have one value more. And let me delete it for now. So for example, here we have our input noise or input ramp or any kind of input, and it have RGB channel. We could connect it to the noise, to the first input and to the second input, and set it to monochrome noise. And as output, we input noise. And now, sorry, let me drink. And now we could use reorder top and connect as a second input this new noise, and we could set the setting the output of this top. For the red, green and blue channel we would use the first input, and for the alpha channel we would use a second input, and because it's a monochrome we need to set it as a red channel. And now let me connect it back. As you could see, the alpha channel is also different. Unlike here on the input, it's letter D. Alpha is all the same, but now in the end the alpha is different. But because, again, let me check back. Because the FOV, if we move FOV just a tiny bit, almost nothing has changed. We need much more movement, like maybe 10, or let's make it 60 back. How much? Yeah, 5 or 10. So we could just go to the noise and increase its amplitude to like 7, for example. So we still have our math top, and our RGB channels move from 0.5 to minus 0.5 to 0.5, so just small movements. And for the FOV, field of view, we want much bigger movements, as you could see here. And that's it for the raymarching. It's, as I promised, it's quite simple. Just oh no, it's not simple. It's not finished because we displaced an RGB channel, but we didn't do anything yet with a FOV. And the FOV is stored in our U camera, so it's like a X, Y, Z, and it's W. So it's here, our FOV. And if you see in the ray direction function, it's somewhere over here. As the first input, it wants a field of a view. So here it is. And we need to add alpha channel from our texture here. Cam displace alpha. And compile. Yeah, and now everything works. And we just add we added 3 lines and such a nice effect. Alright, and as I promised, I'm also gonna explain you a little bit about the noises and the Voronoi. The simplest example is just use a standard noise, a smooth noise or a more boundary noise, and it would look like some kind of smooth displacing, and depending on period you have, depending on the amplitude and everything, the effect could be more interesting or less interesting, but it could be simulated like a waves or like a fun mirror or anything like that. And if you decrease the exponent, maybe increase the harmonics and maybe decrease the period, it's more like a tiling. But I prefer to use it with Voronoi noises. And if you one of my Patreon supporters, I will upload this file with everything done to you on my Patreon. And if not, you can go to Art of the Code channel, very nice channel about shaders. And if you type Voronoi, Martin from this channel explained to you how to code this Voronoi for you. And it would be like this first Voronoi. Actually, I followed almost full tutorial there, but I added a couple of variables and made this component. And it outputs Voronoi. Actually, it outputs different kind of like edges, isolines, this cellular look, and here every of Voronoi cell have a little bit different grayscale value. So if we then look up it with some noise, we got these different colored tiles that we could use for displacing our camera. Is zero input. But if you're not really like this typical Voronoi and want something more fancy, like first input here, this called Voronoi corrects. I also did a shader toy conversion, and this you could use this code. It's a shader toy called VoroCracks and created by Fabrice Niret. And if you don't know how to convert shader toy shaders, you could either use automatic conversion, you could find it on derivative forum or somewhere else, but also I have a big tutorial about how to convert shaders from shader toy, how to add all of these values as uniforms, and how to combine with different tops and chops and everything else. So that's it for today. I hope you like it. Please subscribe to my channel and see you next time. Goodbye.